Welcome to today's Explainer. I am absolutely thrilled you're here because today we are going to decode the world's most famous equation. E equals mc². I mean, we all know it, right? But today we're going to uncover the fascinating, deeply human history behind every single one of its symbols. But first, a quick question for you. Do you actually know what E equals mc² means? A while back, the actress Cameron Diaz was doing a magazine interview. At the end, the interviewer asked if she had any questions of her own, and she said she'd genuinely like to know what E equals mc² really means. They both kind of laughed, but she meant it. And my guess is, if we're being honest with ourselves, most of us feel exactly the same way. We all recognize it, but almost nobody actually understands what it means. So our approach today is inspired by David Bodanis' brilliant book, which is the source material for this explainer. Instead of using confusing textbook diagrams of flashlights and rocket ships to explain the physics, we are going to do a complete anatomical deconstruction of the equation itself. We're essentially going to treat it like a biography.
Okay, let's dive into this. Here's our agenda for today. We're going to cover E is for energy, the equal sign as a telescope. M is for mass, C for celeritas, the power of squared, and finally, Einstein's grand synthesis. You see, this equation wasn't just pulled out of thin air. It was built on the backs of brilliant, often flawed outsiders spanning centuries.
Right, let's kick things off with Section 1, E is for energy, and the bookbinder's whirlpool. To understand E, we have to jump back to 19th century London and meet a guy named Michael Faraday. He was a poor apprentice bookbinder with virtually zero formal education. But honestly, that was a massive advantage. His lack of traditional schooling meant he didn't think like the rigid, buttoned-up scientists of his day. Plus, he belonged to a religious sect that deeply believed everything in the universe was connected in a giant circle. Faraday literally read his way out of poverty through the books he was binding, eventually landing a gig as a lab assistant. Now, while formally educated scientists at the time were totally obsessed with straight-line pushes and pulls, Faraday's religious belief in circles led him to envision invisible whirling force fields. In 1821, he proved that crackling electricity and invisible magnetism were actually linked. He invented the first electric engine by making a wire whirl around a magnet. And this birthed the conservation of energy, the beautiful idea that the total amount of energy in the universe simply changes forms, from chemical to heat to motion, but it is always conserved. Moving right along to Section 2, the equal sign as a telescope, which is way more than just balancing. Because a truly great equation isn't just a boring balance scale summarizing what we already know. Way back in 1543, an eager English textbook writer named Robert Record invented the equal sign for a pretty funny reason. He simply wanted to avoid the tedious repetition of writing the words is equal to over and over again. But centuries later, Einstein didn't just use it as a bookkeeping tool. He used Record's equal sign as a telescope. He used it to direct our attention to a fresh, entirely unsuspected hiding place for energy that literally no one else was looking for. But to understand what was on the other side of that equal sign, we need our third symbol. Section 3. M is for mass and the accountant's rust. For this, we meet Antoine Laurent Lavoisier. He was a meticulous French tax accountant from the late 1700s. The guy was a romantic, sure, but he brought incredibly finicky, obsessive precision to the physical world.
Now this might sound completely counterintuitive, but rusted metal actually weighs more than unrusted metal. Lavoisier and his wife, Marie-Anne, built this completely closed apparatus in their drawing room. They weighed metal, let it rust, and weighed it again. And instead of weighing less as it degraded, it weighed more. Why? Because it trapped invisible oxygen from the air. The total weight of the sealed room never changed. He proved the conservation of mass. Physical matter simply recombines. It is never truly destroyed.
Tragically, Lavoisier's absolute obsession with accounting and building a massive tax wall around Paris made him a major target during the French Revolution. In 1794, he was executed by guillotine, denounced by a vengeful rival named Jean-Paul Marat. But Lavoisier's incredible legacy, the theory of the conservation of mass, survived. So at this point, science essentially had two separate, sealed domains, energy in one box and mass in the other. Which brings us to Section 4. C is for celeritas, the ultimate speed limit. We have energy and we have mass. The letter C acts as the vital bridge connecting Faraday's energy domain with Lavoisier's mass domain. So the C stands for celeris, which is Latin for swiftness. In physics, it represents the speed of light, which is a mind-boggling 670 million miles per hour.
For the longest time, people thought light was just instantaneous. But in 1676, a cocky Danish astronomer named Ole Romer challenged the establishment. By tracking the slightly delayed arrival times of Jupiter's moon Io when the Earth was further away in its orbit, he proved that light has a finite speed. It actually takes time to travel.
Now, why is the speed of light the absolute limit of the universe? Well, think of a surfer. When you surf a water wave, the water can appear to hold still around you. But light is totally different. Thanks to the work of James Clerk Maxwell and later Einstein, we know light is a skittering wave of electricity and magnetism that constantly leapfrogs itself. You can never ever catch up to a light wave to see it stand still, because its very nature is to constantly squirt away from you. That is exactly what makes it the universe's absolute speed limit.
And this brilliantly illustrates Einstein's famous thought experiment. Imagine a space shuttle blasting along at the speed of light. The pilot pumps in more fuel energy to go faster. But wait, nothing can go faster than light. So where does all that roaring energy go? It can't just disappear. The energy gets squeezed and actually swells into physical mass. The ship gets heavier. Energy converts directly into mass. Now for section 5, the power of squared, and a woman ahead of her time. So we have E, M, and C. But why C squared? To answer this, we've got to journey back to 18th century France to meet Emilie du Châtelet. She was an absolute force of nature, a tomboy, a fencer, and a mathematical genius who fiercely defied the brutal sexism of her era to establish a world-class physics lab at her chateau in Cirey. At the time, Isaac Newton dogmatically claimed energy was mass times velocity, or just mv to the power of 1. Under Newton's theory, when objects collided and stopped, energy just vanished from the universe. But du Châtelet looked at data of brass spheres dropping into clay. If you dropped a sphere twice as fast, it didn't sink twice as deep, it sank 4 times as deep. 3 times as fast, sank 9 times as deep. She proved that energy grows exponentially. It is mass times velocity squared. Energy doesn't vanish, it reverberates and accumulates. Her brilliant work proved that squaring the velocity is how nature actually operates.
And this brings us to our final act, section 6, Einstein's grand synthesis and the patent clerk's revelation. Picture this. It's the spring of 1905. Albert Einstein is 26 years old. He couldn't even get a high school teaching job and was stuck working as a third-class patent clerk in Bern, Switzerland.
But you know what? His isolation was his superpower. He wasn't constrained by the complacent academic dogmas of his time. So the crucial point is, Einstein realized that Faraday's energy and Lavoisier's mass were not separate domains. One morning, he woke up feeling the greatest excitement. He realized he could finally synthesize these centuries of historical puzzle pieces. The speed of light is the bridge. Because light travels at 670 million miles per hour, when you square it, you get roughly 448 quadrillion. That absolutely massive number is your conversion factor. It means that a tiny, tiny amount of physical mass acts as a hyper-concentrated sponge, holding an unbelievable, staggering amount of energy. The old equations didn't have to balance anymore. Mass and energy are one and the same. Einstein later said, "We are in the position of a little child entering a huge library. The child notes a definite plan in the arrangement of the books, a mysterious order which it does not comprehend but only dimly suspects. By deconstructing E equals mc² today, we've glimpsed that order. Just imagine the massive, untapped potential quivering inside the ordinary matter all around us right now. The chair you're sitting on, the screen you're looking at, it's all bound up, hyper-condensed energy just waiting to be understood. Thank you so much for joining me on this explainer. I'll leave you with this. If a mere handful of ordinary matter holds that much world-altering power, what other invisible miracles are hiding right in front of us?"